Welcome to Statistical Computing with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll get started with R programming. This is a two-part video. The first part will discuss flow control, functions, plotting, and debugging, and we'll come back with the second video for scoping, reshaping, and some more plotting. So here we are at the course website, and I will scroll down to the table, and we will start Chapter 6 here on writing and debugging code. Slides are available here. Alright, so I'd like to thank Christian Gunning, who was a teaching assistant of mine back in spring 2013, who is primarily responsible for these notes. So here's our outline for these notes. Flow control is largely about looping, for loops, as well as if statements. Functions and how to write your own. Plotting, we'll be talking a little bit about the lattice package, and debugging. So you know there's no such thing as an actual bug in a program. At least computers don't make mistakes as far as we're concerned. It's that sometimes a bug is effectively a mismatch between what we intended to say and what we actually said with code. And debugging is finding those mismatches. So let's remember a little bit about syntax. We can use parentheses to group and for orders of operation. So for example, 1 through 5, this sequence gives us the integers 1, 2, 3, 4, and 5. If we divide those by 10, we get 0.1 up through 0.5, and that's my vector. We can use brackets to index objects. So recall that the minus sign for an index means to exclude that index. So if we take the sequence from -1 up to -2, we are going to exclude the first two indices, which says that my vector of the remaining is 0.3 up through 0.5. We can add up numbers using the sum, and we can put a number of separate expressions on a single line by separating them with a semicolon. So to see what this is doing, I'm going to copy each of these expressions over to the R console that I have over here. Okay, so we have an object AA, which are the numbers 1 through 5. We are creating an object BB, which is the sequence of numbers from 5 down to 1. And then first we're multiplying these two vectors together, element-wise. Okay, so that's 1 times 5 is 5, down these columns. 2 times 4 is 8, and so on. And then we're adding up those 5 numbers by taking their sum, 35. Comment here is try to avoid this. One reason to try to avoid this is that if someone else is reading your code, it's very easy for someone's eyes to initially look at this first part and skip other commands that are happening. Okay? There are times when it's convenient to stack many commands on a single line, but as a rule, or in general, try to avoid putting many expressions on a single line. All right, let's talk about flow control. This will be about the if statement and the for loop. So recall previously my sum equaled 1.5. It was the sum of the numbers 0.1 up through 0.5. And here's our if statement. Okay, so an if statement runs certain commands conditional on something being true or false. Okay, so the condition, the syntax here is if, then some statement occurs in parentheses, and this will be evaluated as true or false. Okay? Or if it's numeric, a 0 is false and any non-zero is true. So in this case, we're asking, is my sum, that which equals 1.5, less than 10? In that case, it's going to be true, and that means that anything in the following braces will be executed. Okay? If my sum happened to be 30, then this expression would be false, and we would skip the commands in the braces. Okay? So if we run this command now, my sum happens to be 1.5, it's less than 10, that's true, and we run these two commands. What do? We take the original my vector and multiply it by 10. That gets us back to the integers 1, 2, 3, 4, and 5. We're going to update that vector, and then we're going to add those values together. So my sum has changed to 15. If else. So here's the same command. If something is true, then do within the curly braces. Otherwise, or else, that means if it was false, then do this series of commands. Okay? So we can append a second statement for what to do when that statement is false, and that's in the else part of the statement. So here's my sum. It equals 15. If my sum is less than 10, do this first thing, but my sum is not less than 10, it's 15. So this statement is false. Therefore, we're going to do the second command. My sum equals NA, and there we have it. It's NA. A for loop. So I want to give a very short demonstration of a for loop and then come back to this page. So I'm going to go over to R, and I'm going to clear the screen with a Control L. And I'm going to write a very simple for loop to show you what the for loop is doing. Okay, let's start with how about a my.list is, and I'm going to just give a few numbers here: 5, 2, 3, 7, 9. All right, so there's my list. Now I'm going to do a for loop for, and this double I is just one way to index the entries that it's going to go over. You can use any variable. Sometimes I use I.my.list. Basically, I append the thing I'm going to iterate over with the I period. But just for consistency with the previous slide, I'll do for I in my.list, open curly brace. Let's do cat II equals II slash n gives me a new line. So I'm effectively going to print what II equals, and then I'm going to close it with a curly brace. Now I'll press enter. It will run this for loop. What did it do? 5, 2, 3, 7, 9. That's this list up here. So for II in my list, so effectively II first time through took the first element of my list and then performed what was in the curly braces. Then it hit the bottom brace, came up back to the for loop and said II in the second element of my list, did what was in the curly braces, and then the third element, fourth element, fifth element, and did all 5. Okay? So II is iterating through whatever occurs in the object following the word in. All right, let's go back to the notes, and now I think this will make some sense. So recall my vector. It is the number, currently the numbers 1, 2, 3, 4, and 5. If we add those up, it will equal 15. Here's a bad use of the for loop. We're going to use it to add up the numbers in my vector. So how do you add up numbers in a vector? Well, one strategy is to first initialize what your sum is going to be. So my sum loop is going to be for this for loop. We're going to add up the numbers. So we're going to start at the number 0, which you need to initialize outside the loop. Then for II, in going through or iterating through the elements in my vector, one at a time, we're going to take the previous value of my loop, which is going to start at 0, add the current element. The first one is II equals the number 1, so 0 plus 1 equals, and I'm going to update my sum loop. So the first time through, my sum loop equals 1. Then II goes to my vector, pulls out the second element, which is the number 2, and then it's going to add the previous sum, 1 plus 2 equals 3, and so on for all 5. So let's see this happen in action. I'll come back to the R console and say my vector, actually let's just see what, ooh, okay, my vector equals 1 through 5. And let me go over and copy this. And we're going to see one issue about copying and pasting from a PDF right here. Notice the curly braces. There's the letter F here. That's an open curly brace. And the letter G, that's the closed curly brace. So sometimes the characters don't copy over correctly. All right, I'm going to add a couple things to this loop. I'm going to cat II equals II, and I'm going to put in a tab character that's a /t, and then I'm going to also print out what the my sum loop value is, and I will end that line with a /n for a new line. So when I press enter here, I'll get some output. So the first time through, II equaled 1. That was the first element, right? One thing I didn't display was my vector, but we saw what I assigned it to be, 1 through 5. So the first time through, II equaled 1. We added 0 plus II equaled 1, and then we looped again. Second time, II equaled 2. 1, this number 1, plus 2 equaled 3. Then the third time through, the previous value 3 plus 3 equaled 6, and so on. 6 plus 4 is 10, and 10 plus 5 is 15. We get to the end of my vector, the last element, and so then we drop out of the curly braces and we are done. Okay, so that's what's happening. If we compare how we got my sum from before using the sum function, which is a vectorized function, works very fast, and we compare that to the sum we got when we added up one element at a time, they are the same. But in general, for loops are a very slow way to add things up or combine things, and we try to avoid them when we can. Whenever there's a vectorized function for something, try that instead. For example, a dot product from multiplying two matrices together element-wise and adding the values is much faster if you do it as a matrix operation rather than looping through elements of pairs of vectors. All right. When is a for loop required? Well, if each iteration depends on the previous iteration, then it's hard to get away from a for loop, unfortunately. So one example of this is Fibonacci numbers, where the next number in a sequence depends on the sum of the two previous numbers. All right, so let's start with n equals 10, and my fib is a list here of just two elements, 0 and 1. And this is actually a very inefficient way to do this, and I'll describe why in a second. But this does work. So here's a for loop. We're going to start II goes from the second element, or rather II in the number 2 up to n. So let's see what happens here. So when II equals 2, the first time through, II equals 2. So my fib, II is the second element, right? It's II equals 2. So what is my fib? What is the second element of my fib? That's the number 1. So this value is the number 1. My fib II minus 1, okay, so II is currently the number 2, so 2 minus 1 is the first element, that's 0. So this whole expression is 1 plus 0. We're assigning that to the next index, II plus 1. Now that index does not exist in my fib right now, because my fib is only a list of 2 elements. So it actually needs to create a new version of my fib, copy the previous version of my fib in as a 2-element list, and allocate a third element where it's going to put this value, and that's going to be the number 1. That made that number there, the number 1. Then we hit the end of the for loop and we loop back. Then II equals 3, and so then we take the third index, which is number 1, plus the value of my fib at the 3 minus 1, the second index, 1, add those two numbers together, and assign that to the next index, the fourth index. So the sum of that is equals to 2. And then we loop around. And we do that over and over again, and we generate the Fibonacci sequence. All right, writing functions. So anything you do in R can be turned into a function. And I strongly recommend, whenever possible, to write a function for an operation that you're going to repeat more than once. Functions will make your life easier, and it's so important to comment the function code to explain the behavior. Why are you doing this operation? Explain your reasoning as you go through. And sometimes the how are you doing it, so that when you look back at your function, you can just read your comments and it will make sense to you, rather than trying to decode some cryptic set of symbols. All right, so let's write a function for the Fibonacci sequence. There is a function called function, which helps you define a function. So our function is going to be called makeFib, okay, mk.fib, and we're going to end up using it down here like this, where we ask for 5 numbers of the Fibonacci sequence, and it gives us actually 6 numbers, so it gives us the first 2 numbers plus 4 more, okay? So this function, makeFib, is going to take 2 arguments, and those arguments appear, sorry, I'm having trouble highlighting only what I want, appear in the parentheses, the round parentheses. The first argument is n, okay, that's the number of integers to return plus 1. And then the seed is going to be the previous 2 elements, or the 2 numbers of the Fibonacci sequence that you're going to start with, right? The traditional Fibonacci sequence starts with 0, 1, but it could start with any pair of numbers. And there are interesting sequences that are generated from other seeds for the Fibonacci sequence. So, what do we do in the Fibonacci sequence? Well, the first thing we're going to do is pre-initialize a vector. This is what we didn't do in the previous slide. We can do this now because we know how many elements we're going to create. Okay, we're going to create a vector of length n plus 1, and we're going to initialize it with na. So rep repeats the value na n plus 1 times. So if n was the number 5, for example, down here, we're going to get a string of nas that are 6 long. So that would be 6 nas. Then we're going to initialize the first 2 elements of the fib list with the seed. So in that case, it's 0, 1. So now we've got the first 2 elements, 0, 1, initialized. Then here's the same loop that we had before. So we have the for I in 2 through n, and it goes through and it iterates all the way through. And then finally, a function takes inputs and it returns an output. And this return statement indicates what value to return. It's going to return the list fib. All right, so let's use this function. Make fib 5 gives us the seed 0, 1 as the default. Now notice here we have actually specified a default value for seed. So we don't need to specify it. And if we don't, it starts off with 0, 1 as the initial values. We do, however, have to specify n. It's not pre-specified. So 5 gives us the first 6 numbers, and 10 gives us the first 11 numbers. All right, let's page down. What happens if we start with a different seed? So now we're going to specify the second argument overriding the default. So we're going to start with 5 and 8, and we're going to get 5 numbers from that. So we start with 5, 8, and then we get the next 5 numbers. All right. And as long as you are being clear and specifying what variable you're assigning, notice in the first case we had just the number 5. Because 5, I'll page up for a second, because n is the first argument in the function, then the number 5, make fib 5, this 5 is going to automatically be assigned to that position, or the argument in that position. So n is the first argument, therefore 5, or n equals 5. If you indicate which variable you're specifying, then the order doesn't matter. So n equals 5, seed equals this, it doesn't matter which order it's in. It will give you the same result. If you omitted the word seed equals and n equals, this would not work, because it's expecting them to be in the other order. All right, debugging. First of all, read your error and warning messages, and read every word and character of them and try to make sense of them. Often I see people debugging code or writing code and they keep getting warnings. They fail to read it. They just go back to the code and scratch their head and try something new. And had they read their warning or error message, it would give the information for what to fix. All right, so let's see what's happening here. My vector is going to be the numbers 1 through 3, each divided by, and so this notation is a scientific notation within R, 1e6. The e here stands for times 10 to the power of. So let me just show you what that is over here. I'm going to clear my console. 1e6. Enter. Okay, that's unfair. 1e4. All right. 1e4 is 1 times 10 to the power of 4, so it has 4 zeros after the 1. You can do 2e4. You can do 2.5e3. Okay? And all that works the way you would expect. And R, for the sake of not having so many digits presented by default, once you get above a certain range, will start to represent numbers in scientific notation. All right, so anyway, let's take a look at this expression. Okay, so my vector. So at 1e, so we haven't looked at these yet. 1e minus 3 is 1 times 10 to the minus third power. Okay, so that's correct. So my vector here is 1 millionth or something like that. 1/100,000th, 2 100,000ths, 3 100,000ths. And I dare you to try to say that very quickly. All right, so what are we doing here? From II in 1 through my vector, print II. Okay, so that seems pretty clear. We're going to go from the first value up to my vector. So my vector, as we've already seen in R, is this list of 3 numbers. Therefore, if I run this and recall, I've got my curly braces that don't work from copying from a PDF. We get this warning. 1 to my vector numerical expression has 3 elements. Only the first one was used. So I get print II. So II was printed as 1. The number 1 was printed and nothing else. What were we expecting to happen? Well, probably we were expecting these 3 numbers of my vector to be printed out. Okay, so what are we doing? So if there's an issue, so this is saying warning in 1 to my vector. Okay, so let's examine what that expression is. Let's copy this and paste it into R and see what this looks like. Oh, it didn't like it. All right. Numerical expression has 3 elements. Oh, my vector has 3 elements, right? So what is a list of 1 up to, oh, that's where it doesn't make sense, right? Because you can make sequences of 1 up to 4, but you can't make a sequence of 1 up to 2 different numbers, 4 and 5, because this is confusing. Do you want to go from 1 up to 4, or do you want to go from 1 up to 5? Okay, this doesn't work. So that is where the issue is happening. So another way to look at this is, what's the length of my vector? It's 3. That's the 3 of the 3 elements in the warning. And so this is actually probably what we wanted to do. 1 up to the length of my vector. This is a handy way to loop. All right, so here's what we wanted. Perhaps for II in 1 up to the length of my vector, therefore we're indexing the position along my vector, the first element, the second element, and so on, and we're going to print those indices. So we get the first element, second, 2 up to 3, 1, 2, 3. Or another thing that we might have wanted was for II in my vector, which is what we did before, and then it's going to go through each value of my vector. And when we print each value, we get these 3 numbers here. All right. But yes, as we've seen, that didn't work. So this is very common, or 2 common ways to use the for loop. Either to loop through the indices of a vector, so 1 through the length of that vector, or to loop through the actual values of the vector. All right. Inspection. So let's look again at the Fibonacci function, the make Fibonacci. All right. So something wrong has happened in this code. So can you see what's wrong? Something has changed. In fact, consider pausing the video here and looking at this function and seeing, why do we get, when we run this function, why do we get this error? All right. Pause the video and come back when you see the mistake. All right, I presume you've taken a look and come back. What's wrong? So the error is error in seed this line, okay? Replacement has length 0. So there's something in this line that's broken. So what is broken about this line? Let me page down for a second. So there's ways of trying to debug the issue, and here's the first place to start, okay? Add print. Okay, so let's print II, and let's print the value of seed, and take a look. So make fib 5. So imagine we've resubmitted this function to the command window, so we've defined that function. Now we're going to test it with make fib 5. So the first thing it does is n is defined as 5, All right. Seed is defined as 0 and 1, that list, 0, 1. For II in the list 1 through n, so the first time through II is going to equal 1, and it's going to print 1. That's this output here. Then we're going to print seed. Remember, seed is the list 0, 1. That's this. Then we get to this command, and we get this error. All right, so the error happens when we get here the first time through the function. All right, did you raise your hand because you saw what's wrong? Good, you can put your hand down. All right, here's another way to debug this. It's a function called browser, and you can put this into your function, and when you run it, it will, let me just show you. It'll actually stop at browser and allow you to inspect the different elements or objects in R that exist. All right, we can look at II, we can look at seed, we can actually, so I'll show you everything that we can do. So I'm going to jump over to R, and I'm going to clear the console, and I've prepared this bit of code right here. This code is the same as what we were just looking at in the slide. And the only thing I've done here is I've uncommented the line with browser. Okay, so if I go back over to here, here's the browser line, and I've removed the pound sign. So I'm going to submit these lines by highlighting and pressing Control Enter. That will put them down into the console and submit it. All right. And actually, one thing I want to show you here is if I type make.fib and press enter, it will show me what that function is. There's the function makefib. And if we look up in the environment up here, there's values that have been defined, and there's also functions that have been defined. And there's the function. I clicked on it, and when I clicked on this function over on the right, it ran this line view makefib, and in the top it created a new window, or opened a new window, source viewer, and this is that function. So it would allow me to scroll through and look at this function. All right, so I'm going to close that. That's just some additional functionality. So now, remember what we're looking at. We've input the command browser, and we're going to see what the functionality of that is. So now I'm going to press Control Enter on makefib 5, and look at what browser does. So down at the bottom in the console, I have a new command prompt: browse 1 greater than sign. Okay, so we have a browser prompt. So from the browser prompt, we can do lots of things. I'm going to actually do a !browse browser and press enter. That's going to bring up the help for browser. And I recommend having a look through here. I'm going to scroll down and look at what some of the commands are for this function. C, it means to continue, and it's going to run the next statement. F finishes execution of the current loop and goes to the next. I can look for help. In fact, I'm going to, over here, I'll type in help and press enter. And it does give me a series of commands that I can use at this prompt, and so on. All right. So while I'm at this prompt, I can evaluate some of the values over here. So for example, I'll look at what n is. N equals 5. That was the input that we used when we ran the function. That was here. Okay. Then we can look at seed. What's seed? It's 0, 1. What's II? It's the first element. Okay. So now we know that the error happens when we get to the next line. In fact, let me down here, I'm going to press C to continue and press enter. Okay, we got the same error that we got before. and the browser window went away up here. So let me run this again. I'm going to press the up arrow in the console, and that will bring me back to the browser window because it's going to hit that line, and it reopened this source viewer up here. So something is wrong with this next line. Let's take a look at what is going wrong. So let's look at seed II. I'm going to highlight that and press Control Enter. That'll submit it down in the console. That's the number 0, right? Because II is 1. So the first element of seed is 0. How about this line here, this element? Numeric 0. So what's happening here? II equals 1. So 1 minus 1 is 0. What is the 0th element of seed? Well, that doesn't exist. In R, indexing starts at the first position, at 1. Therefore, there is no element at position 0. So we're trying to add the number 0 at the first position to a numeric but not defined value at the 0th position. And that is the problem. Why did that happen? It happened because the thing that changed in the function was the number 1. So this was the mistake. We started the indexing from the first position. So when we looked back one position, we were looking outside or beyond the end, the beginning of the vector. So that was the mistake. Cool. So browser gave us what we want. We can press C. Well, actually, let's type help and see what other options we have. We can say N for next. Debug at number 6. So that's at line 6. But if we do N again, we get the error. Okay, and we get out of browse because the error ends the execution of the function. Perfect. Next slide. All right. So we've done all of these components in R just now. I'll page down. All right. Here's some suggestions to end this part of this video. You want to write good code in as little time as possible. So when you get stuck, take a break. That doesn't mean that every time I get stuck and then I hammer away at it for a little while and often I will fix it. But if I really get stuck and I can't go anymore, if I start getting frustrated, that's not going to help. If I get upset, it's not going to help. And if I get tired, I may end up stuck for a long time. Okay, so take a break, go do something else, and then come back to it. Often fresh eyes will find mistakes quickly. Also, ask someone else to look at your code. Sometimes that is the best strategy to do, because you've looked at the code you've written, you know what you intend it to do. When someone else looks at it, they have to look at it with fresh eyes. They have to understand it from the beginning, and they will often see mistakes that you are blind to. All right. Second comment here, learn your text editor. Okay, there's keyboard shortcuts which will keep you from moving your mouse around all the time and clicking everywhere. You will be much faster if you can keep your hands on the keyboard. Proper code indenting, we can cover that in class a little bit. And then syntax highlighting we see in R, right? We have text in here that's all different colors. Comments are in light gray in my current setting. Reserved words or functions are in brown. Numbers are in this reddish color. And then other variable names and things are in white. Anything between quotes here is green. Right? So those different colors help me see or move my eye to different objects that have different meaning. And what the heck, let me show you indentation. So if I say I remove all this indentation in my function, you will find that once I remove this indentation, this is now a very hard chunk of code to read. Whereas before you could see where the function began and ended, and where the for loop began and ended. But now you cannot. So if you highlight this code, there is under code re-indent lines. I think that will do it. And the command for this is Control-I. So I'm going to press enter here, and look at that. It indented it just as you would like. And if you do other things to it, okay, make the indentation crazy and highlight it and press, now this time I'm just going to press Control-I. It fixed it. Man, that will make your code readable. Just do Control-A to highlight everything, Command-I, and your code will instantly be more readable than it was before. Alright. There are, I should say, other keyboard shortcuts inside R. So if you go to the Help menu and go to the keyboard shortcuts, you will get a whole list of them. These first set, Control 1, 2, 3, 4, and so on, move the focus from different windows. Let me just show you that. So right now the blinking cursor is in the first window. If I press Control 2, that cursor is going to move from this window down to the console. Here we go, Control 2. Now it's down here. Now if I do Control 3, it's going to move it to the next window. Control 3, that's the help window up here. Control 4, opens the history. Control 5, goes down to files down here. Control 6 is plots. Control 7, packages. Control 8 is the environment, the variables that you have. Control 9 doesn't seem to do anything. Control 0 doesn't seem to do anything. The main things here are basically Control 1 and 2. When you press Control 1, you're in the source window. When you press Control 2, you're in the console. So you can go quickly between those two places. Alright. Seek help. You can look for functions, for help with functions inside of R. You know, you can Google things by typing R space and then your question. And when you ask questions, ask good questions. And I have a comment about this on the website about what is a minimal, commented, fully reproducible example. It is a small set of code that effectively gives someone else a way to reproduce your problem and then suggest something that fixes it, and they can see that it's fixed and you can see that it's fixed. Alright, so that's the end of this first section on flow control functions, plotting, and debugging. Come back for the second part for scoping, reshaping, and plotting.